Hey, everybody. Nice to meet you all. My name is Jonathan Victor. I work for Protocol Labs on NFT Storage. And yeah, today I wanted to talk to you a little bit about where your digital art lives and what actually happens when you have an NFT. But maybe to start, I wanted to start with two stories. I don't know if anyone's familiar with these two, but hopefully they're familiar. A story of rugs and bubbles. It wouldn't be a talk about NFTs without that. So on the left here, we have the Rugs project by Neither Confirm. Basically what happened was Neither Confirm launched a project where they had all these NFTs of like crypto personalities on Twitter, and then subsequently rugged out the project by literally switching the images to pictures of rugs. And then on the right, we have the story of Fuck Bubbles, where Fuck Bubbles were these NFTs you could buy. They were all sort of like little gimmicky ones. But then the artists would routinely hijack the NFTs and swap them out for just whatever advertising for the next project, things like that. And I think for folks who are maybe newer to the NFT space, this might be a little bit confusing. Things people might have heard is that NFTs are permanent, they're stored on the blockchain. So how is it possible that someone could take an NFT and change the content? And so to explain this, it's worthwhile to dive in a little bit to what an NFT is. A little disclaimer, this is just one token standard for Ethereum. There's other token standards for other L1s, but this is by and large what you'll see. So on the left, what we have is the metadata spec for the 721 token. You can see that an NFT sitting on Ethereum has three main properties: a name, a symbol, and a token URI. And a token URI is just a link. And that link will have to point to what's called a JSON blob. And that's literally just another blob of data that has more information about what the NFT should be. So like that thing on the left is actually what is sitting on the blockchain. That is your NFT. The thing on the right is an example of what you might see if you actually pull up that JSON blob. So what is like that token URI returning? It's returning some information about your NFT, a description of it, maybe some like specific traits. But most importantly, I can't tell if you can see the little highlight here, it has an image URL. And that's the thing that's actually shown when you go to OpenSea or whatever other platform that's showing your NFT. And so if you look at this image URL as an example, you'll see that it has HTTPS. That's just a link to your content. And so this is actually how we can explain how those NFTs were changing. So how do we know what was actually happening? Well, with HTTPS, what we call that location-based addressing, you're pointing at someone's server. You're saying, hey, my image is going to be living at johnsdropbox.com/JPEG1, and you're sort of trusting that whatever is at the other end of that URL is actually your content. And of course, that's like not a very good thing. If you're thinking about an NFT and you expect this thing to stand the test of time, I don't want my NFT to point at someone's server. I want it to point at actually the image that I care about, wherever that image may be. And so how can we do better? So IPFS is a project which actually, it's an open source piece of code. But IPFS is a way where you can store and retrieve content not based on where that content lives. It's not based on a location. It's based on a fingerprint of the content. So to sort of explain, we see our little Nyan cat at the bottom left over here. And that Nyan cat, you can take it and put it into IPFS, and you can get what's called a CID, which is a content identifier, or you can think of it like a fingerprint of that content. It's just a unique identifier for that content, which your computer can now use to ask the internet for that data. Now that data, it may live on a specific cloud server. Maybe that's run by Salesforce, who just announced they're going to mint NFTs. But it could also live on your own computer. It could live on a decentralized storage network. It could live anywhere. And the important property is that your computer can ask anyone for that data, and regardless of who sends it back, you can verify it's the thing that you were looking for. So you can sort of see in this example, this computer on the left is asking IPFS, or over the IPFS network, hey, does anyone know about this specific fingerprint? Whether that comes off of AWS or some other random computer on the internet, it can now verify that it got the right picture back because that picture matches the fingerprint. Of course, that doesn't solve every problem. It sort of implies that someone is holding on to that data somewhere. And so if no computer on the internet has that data, well, that fingerprint's not going to resolve to anything. So the next question then is, how do we solve for this availability problem? How do we make sure that someone on the internet actually has this data that we care about? Unfortunately, this is where Filecoin comes in. So Filecoin is a decentralized storage protocol The way to think about it is Filecoin allows you or anyone to store data on this network of peer-to-peer storage providers, and these providers are required to do a couple things. Thing number one is they're required to basically enforce a cryptographic, or the blockchain itself is enforcing a cryptographic SLA. Effectively, the miner has to prove to the network that they're still holding on to the data that they were given. They have to do this every 24 hours. They use these really cool ZK snarks. But it's a way that the blockchain can verify that the data that's supposed to be where it's supposed to be is actually there. Thing number two, Filecoin is incredibly large. The storage capacity, this slide is actually out of date. It's now at 17 exabytes of storage. To put that in context, CERN has like about 100 petabytes, so it's like 170 CERNs worth of data capacity that's on the network. This is like Google in 2014, 2015 scale that we're talking about. And lastly, it's super cheap. Because we have so much scale, miners are hyper-competitive trying to get people to store data with them, which ends up meaning that it's literally fractions of a dollar in order to store a terabyte of data per year, which your NFT is almost definitely smaller than a terabyte. So putting this together, why does all this matter? So IPFS and Filecoin are trying to do two specific things and two separate problems, solve them for NFTs. So IPFS is solving that reference problem that says, hey, what's the thing I'm going to stick in my NFT to make sure that my NFT is not linked to one specific server or even one specific storage network? I want my NFT to be linked to the image or the asset that I care about. And Filecoin is offering the other answer to the question, which says, well, how do I make sure someone is holding on to that data somewhere, regardless of how large it is or how many there are? I want to make sure I know for sure that this data actually exists. And I think maybe to underscore why this is so important, I think a lot of times when people talk about NFTs, they focus on a subset of the use cases. They think about maybe just like the picture use cases or maybe like videos. But really, if you sort of take a step back, NFTs are the first time that we've had digital bearer objects ever. Like every object that we've had in Web 2, whether you think of like a Fortnite skin or whatever else, those are digital objects that required and sort of implied the existence of a specific company or a specific entity holding up their end of the bargain. NFTs now uncouple users from that sort of paradigm. And so without having these decentralized storage technologies, we're actually still implicitly holding ourselves tethered to specific companies. And so building things that scale, especially if you believe that the internet is going to have literally billions of these things as NFTs and wallets and gas fees hopefully go down. But as these things become much more proliferated, we're going to see NFTs that are more things, whether they're tickets, game assets, music. If you look at Lens, like social media posts, we're going to see these digital bearer objects everywhere. And so in order to make sure that we can actually meet internet scale, we need internet scale storage. And so yeah, NFT storage, this is a really simple way. If you're a developer who's trying to build on decentralized storage tech, you don't have to be an expert to get started. NFT storage is a public good. This is completely free to use. It uses IPFS and Filecoin in the background. There's a bunch of different services that maybe we could touch on as well. There's a gateway, so if you're trying to make really fast retrieval so it's delightful for your users, there's that. Mutable NFTs are coming, so if you have a game where you have a Charizard NFT or a Charmander NFT and you need it to evolve into a Charizard, how do you do that in a decentralized and verifiable way? That's coming to NFT storage as well as tools where if you're doing batch uploads, you have a new 10K PFP drop, you literally can just drag and drop your files and have it be good to go. So yeah, with that, maybe I'll pause there, and open up for questions.
Is there a mechanism within this system to ensure that the data hasn't been altered or copied?
Do you want, yeah, if you want to ask that again in the mic.
Is there a mechanism within this system right now to ensure that data is not altered or copied, to ensure that it remains unique, which is kind of the premise behind NFTs?
Yeah, so maybe to go back, if I can. Cool. So that CID is actually like the root of what's called a Merkle tree. So it's like you take the data, you chunk it up into these like, I think they're 2 megabyte blocks, and then you're getting a cryptographic hash of that. And so when you are storing the data on Filecoin as an example, that's actually getting encoded into a sector, but that, it is tamper resistant is the point. But yeah, and then the cool thing is when you request the data back, you can verify each of these individual blocks to make sure that it's actually the thing that you were looking for. So both on the storage and on the retrieval, you can do what you're talking about, which is like the verifiability side. See one in the back.
Hello, you mentioned NFT Storage as being free.
Yeah.
How's how's it free? Who's paying for the hosting and the bandwidth, et cetera, et cetera?
Yeah, that's a great question. So there's two sides of NFT storage. There's IPFS nodes and there's Filecoin behind the scenes. So the IPFS nodes are run as a public good by Protocol Labs. So that's just like paid for. The Filecoin side actually is leaning into Filecoin's crypto economic model. The way Filecoin works, miners earn higher block rewards for storing data. So in their case, they're actually competing to store data because it earns them higher block rewards. Later this year, when Filecoin launches smart contracts, NFT storage, the backend is turning into a DAO. The plan is actually to lean into DeFi for perpetual storage, where you literally will just seed it with a treasury. That DeFi will use the yield to basically continually fund the storage. If you're interested, I can talk you through how we're planning the economics there. But yeah, that's the short answer. Cool. Yeah, one more.
Hi there. You mentioned gaming assets and evolving them. How does that work through your system?
Yeah, so this would be leaning into something called IPNS, which is the Interplanetary Naming System. So typically, when you have these CIDs, what you're doing is you're taking the image itself, chunking that up, and then using that as the reference. With IPNS, what you actually do is you create a public key and use a hash of that public key as the reference. And then only that public key can update what that public key is pointing to. And that's like advertised as a record in the IPFS DHT. So the plan would be to use IPNS to make that happen. So then anyone can verify that anyone can verify the relationship between that hashed public key and the latest CID, so the latest fingerprint of your data. And only the person who owns that public key is able to update what that thing is pointing to. So then you can have the ability for someone to verifiably update data while also having sort of that lineage of what the data was.
And is that the person that owns that gaming asset as an NFT, or is that the company that has the IP, or are they the controlling factor that has that influence?
So that would depend on how whoever is implementing things set it up. You could kind of set it up both ways if you wanted to. But users can be in control of that end key. So if you want to make it such that only your users are the ones who can update the content, you totally could do that. Yeah.
Thank you very much.
See one over here.
How might NFT storage compare to, say, holding NFTs on cold storage or something else? Because I know there's been a lot of issues around people having NFTs stolen out of their wallets, say if you're holding them on MetaMask or on OpenSea or whatever. I don't even know if those two things compare, where you would securely hold your NFTs, but it's been one thing that's been a big concern for me personally, of how am I storing these and keeping them in a hot wallet, or where do you keep them?
Yeah, that's a great question. So let's go back here. So I think the important distinction is the token itself. That's typically what people are talking about when they say store that token thing on cold storage. You want to make that sure that's on a private key that's disconnected from your normal internet laptop. So if you get phished, it's not going to compromise that key and allow someone to sign a transaction that moves your NFT out of your wallet into their wallet. Separate from that, though, remember that the NFT that's sitting on Ethereum or Solana or wherever has that token URI. The thing that NFT storage is solving for is to making sure that token URI always resolves to something, regardless of what happens to the asset on Ethereum itself. So it's two separate problems that they're tackling. Which, by the way, if you are a collector, you could run your own IPFS node. There's a browser widget. If you use Brave, the browser, actually this is already embedded in there. But you could literally just, if you want to solve for that storage problem yourself, you don't even have to use NFT storage. You could literally just store the data on your own computer. So take it into your own hands. One more in the back.
Yeah, considering old blockchains like Namecoin, something like that, that has a renewal process, is that a feature that will be built into this eventually, or is that not so much on your radar?
What do you mean by renewal process?
So basically, assets expire after 36,000 blocks, for example. So right now, you have to go in manually, renew the asset, or someone can basically come and snipe that.
Yeah, so the way Filecoin works is it uses term-based deals. This is actually a cryptographic reason for it, a security requirement. However, with smart contracts, you can basically just automatically renew these deals. So the plan is just literally smart contract, pool of funds, auto-renew CIDs. So like you literally just say, Filecoin, make sure there's always 5 copies of this data on the network for me. Yeah. Cool. Can't tell if there's more hands, but oh, yeah.
Yeah, I was just wondering if you could speak to the performance characteristics of rendering IPFS files to the browser versus a normal HTTP resolved file.
Yeah, that's a great question. So IPFS, there's a bunch of different ways you can tune it. NFT Storage actually, because it has a giant index of NFTs, has a gateway that's tuned to like serve the IPFS content itself. So if you want to peer with the IPFS or the NFT Storage gateway, and you're using pure IPFS, that should actually be really quick, because the way IPFS works is it'll first check your node, it will then check the nodes that you're peered with, it will then go to the broad DHT. If you just go to the DHT, that might be slow, but it will find it wherever the content is. So one way you can improve it if you're using pure IPFS is to peer with gateway nodes that might know where the content is. But you can also, if you want, like just use a gateway over HTTP. So like, again, NFT Storage is indexed. You could also hit it over HTTP, and that's going to be as fast as HTTP is. The benefit sometimes with IPFS is if you're working with like a bunch of nodes who all are storing the data, then you can download the data from many different people, and that can speed things up. So a good example of this is like Gala Games. If you're familiar with them, every node that Gala has are all IPFS nodes that are all storing the same content. So when one new node comes online and is like, hey, I want the data, it's not just downloading it from one server, which would happen with HTTP. It's actually downloading it from like 14,000 servers, and that makes it much faster.
Thank you.
Yeah.
Okay, thank you for your speech. First of all, you mentioned that NFT storage is free, right? But then how would Filecoin benefit from storing NFT data? And you said people will be competing for storage, but we are, for example, right now we are in a bear market, so it will be kind of less attractive for people to compete. So is there any protocols for that?
Yeah, so how does Filecoin benefit from NFTs is the first question. The second question is, will people continue to compete for deals? So on the first one, I actually think it's much more interesting to think of it as like a loss leader sort of thing. For miners, there's actually multiple revenue streams. So one is storing data, one is retrieving data. I don't know if folks were here 2 days ago, but like compute over data is another really big one. And then of course, just sort of like smart contract use cases. And so for miners, there's a lot of incentives outside of just pure storing data on the network where they can offer other services in the future. So especially when we look towards like retrieval and like caching data, and especially for highly requested content, you think about like the Bored Ape Yacht Club, or if you're thinking about like metaverse type use cases, that can actually end up being much more profitable for them. So storing as like an archival service is like totally fine. Sort of along those lines, if you look at like miners' revenue streams, to answer the second question, block rewards is just one. It just so happens that today block rewards are still the dominant feature. But if prices of block rewards go down, miners would then switch to just saying like, hey, we need to charge more for retrieval fees or storage fees or things like that. This is actually where smart contracts get quite interesting, where like if you actually want to price perpetual storage, I would argue the way that you do this is you sort of look at like what are the cost centers for miners, and then index your input based on that. So like for NFT storage as an example, the way that we're designing this, it would have a pool of USDC, a pool of Filecoin. Both of those things generate yield. One maybe goes into compound, one goes into lending to miners. But then for the actual miners, even if like the price of Filecoin goes down, you still have the diversified revenue stream from the USDC side that can continue to pay costs. Yeah. Yeah. Cool. Sweet. Well, I guess that's it. Thanks, everyone.